for today. Okay, so we have universal conditional statements. Now we were talking about negations in a couple of previous videos. So what about the negation of universal conditional statements? Okay, so the negation of for every x, if p of x, then q of x, this is equivalent to there exists x such that and not q of x. Okay, so let's think about this logically. We're saying, look at the inner side of the parentheses, and this statement is saying, for every x, if p of x, then q of x. Okay? We want the negation of this statement. So, the negation of that statement would be that there would actually exist some x such that this statement is not true. Okay? So, to make this statement not true, you would have p of x being true and q of x not being true. Okay? And some of these get into kind of strange logical arguments, but let's look at one. Let's say the negation of every valid argument All right, I want to write this in a slightly different way because this isn't exactly clear how this is a universal conditional statement. Okay? So I want to try to get it into this notation that I have up here. Okay? And so I'm going to try to isolate what my P and what my Q are. Okay? So if I wanted to rework this thing, I could say, what about the negation of, for every argument, if it is valid, then it has a true conclusion. Okay? So, our x's are our arguments, and the question becomes, is it a valid argument? Does it reach a true conclusion? Okay? Well, the negation of that statement would be that there exist arguments and then we'll say such that are valid Okay, so that's a negation of a universal conditional statement.